Central limit theorem and the sampling distribution of the sample mean, also called x bar, given. Population with any distribution has a mean and a standard deviation. Simple random samples of all size n are selected from the population. Practical rules for real applications involving a sample mean. Requirements which are the population that has a normal distribution or that n is greater than 30. So the mean of all values of the sample mean is the mean of the sample means, which is equal to the mean. The standard deviation of all values of the sample mean. The standard deviation of the sample means is equal to the standard deviation divided by the square root of n. And the z-score conversion of the sample mean is z, which is equal to the data value minus the mean divided by the standard deviation. Now, original population is not normally distributed and n is less than or equal to 30. The distribution of the sample mean cannot be approximated well by a normal distribution, and the methods of this section do not apply. Considerations for practical problem solving. Number 1, check requirements. When working with the mean from a sample, verify that the normal distribution can be used by confirming that the original population has a normal distribution or the sample size is n greater than 30. 2. Individual value or mean from a sample. Determine whether you are using a normal distribution with a single value x or the mean from the sample mean, from a sample mean of n values or a sample of n values. So, the individual value, when working with an individual value from a normally distributed population, you would use this formula, z, which is equal to the data value minus the mean over the standard deviation. Now, when you have the mean from a sample of values, so when working with a mean from a sample of n values, be sure to use the value of the standard deviation divided by the square root of n for the standard deviation of the sample means. So you would use the following formula, where z is equal to x minus the mean over the standard deviation divided by the square root of n. So the following new notation is used for the mean and the standard deviation of the distribution of the sample mean. So here's a notation of the sampling distribution of the sample mean. So if all possible simple random samples of size n are selected from a population with a mean and standard deviation, the mean of all sample means is denoted by the mean of the sample means, and the standard deviation of all sample means is denoted by the standard deviation of the sample means. So again, here's the mean values of the sample means, and there's the standard deviation of all the values of the sample means. And then make note that the standard deviation of the sample means is called the standard error of the mean and is sometimes denoted as SEM.